Hello and welcome back everyone. Into this video, we're going to talk about building blocks in robotics. Now, this chapter 2 of module 2 is quite an essential part when we are starting to understand how robots are being constructed, and all these construction in robots requires the understanding of the components which are being used. Now, I'm going to be specifically talking about how and what exactly happens when you're selecting a particular component. But before we do that, in this chapter, we're going to understand what all these components that are going to be essential for a robot. This also includes the part where we talk about mechanical components, electrical components, and also programming-based software components. But we'll start with simple steps. So this module is going to give you an overview of that, and then we'll move further. I hope you're excited, and let's get started. Okay, let's start. So we have building blocks. Okay, so building blocks are basic components that are used to create a robotic system, and that's what calls them as building blocks as well. Okay, we call them building blocks because they're essential components which are going to be extremely important for building a robotic system. Okay. Now, building blocks can be combined in various ways or various complex systems. Robotics systems with complex function capabilities can have multiple or more and more complex blocks, of course. Okay. And these blocks essentially talk about how your robot is going to work. There are several types of building blocks used in robotics, including mechanical components, electrical components, and software components. As we already discussed before in a couple of chapters, that its robotic system is essentially consistent of a lot of components, okay? And all of these components can be very huge or very small depending on what exactly are you building, okay? If it's a very complex system, it can have multiple sensors and multiple controllers. Let's take an example of an airplane, okay? An airplane has over 1,000 small computers which are analyzing all the performance data and figuring out if everything is happening right or not. Okay. Now, when you have a dependency of such high number of controllers, you need to make sure that everything is working well and everything is working at a very good rate as well. Okay, and that's what make these components and complex machines extremely complex, and robots extremely complex as well. Okay, let's break it down. Okay, let's break it down to two sections first. Okay, mechanical components, including the robot's frame, joints, and end effectors. We already talked about robot frame, joints, and end effectors a little before. Now we're going to go a little more deeper. Electrical components, including the robot sensors, actuators, and robotic systems. Okay, control system. Now, control systems, sensors, actuators, also we touched it a little bit upon before, but now we're going to go a lot more deeper. But these are the two essential components that you see from a robot. Okay, when you look at a robot, these are the things that you see from front. So software components includes the program and algorithm used to control the robot's behavior. Okay, and let's talk about robots which are going to behave with humans. Okay, you need to make sure that the robot is capable first. Second, it's autonomous, so it can think. And third, it can make decisions according to a particular situation. Okay. Now, thinking is not only enough. Critical analysis of a situation is something which is going to be very important for a robot. If the robot cannot think about a critical situation and do critical analysis, then it's probably not really a good robot for that use case. And that's what makes and differentiates a good robot from a really good robot, actually. Moving forward, we have importance of building blocks. Okay, building blocks are important in robotics because they allow engineers and researchers to design and build robotic system with different functions and capabilities. Okay, when you have different functions and capabilities, you need to understand that all of these capabilities are need to be added into the system. And that also means that a robot will have a lot more mechanical and electronic components, and controlling all of those would have a lot of software components as well. Okay, so which means we are actually doubling, in fact, tripling down the amount of components which are going to be there, which is going to make this robot a very gigantic system on its own. By combining different blocks, it is possible to create a robot to offer various applications such as manufacturing, healthcare, and space exploration. And all of these, of course, are like, they're not easy. They require a lot of planning. They require a lot of, a lot of thinking, a lot of, different use case planning. It's a huge amount of, steps here and there. So, it's not really an easy task. Example of building blocks. Okay, some examples of building blocks used in robotics include motors and gears for providing rotary or linear motion to the robot joint. Okay, when you have a robot joint, okay, you need to provide both, all kinds of motion to that robot joint. And that's when this comes into picture, when you need to have like a lot of motion into play as well. Sensors such as cameras, sonars for detecting, measuring the robot behavior. Essentially, when a robot is doing something, you need to measure all these parameters and figure out, okay, if I told the robot to move 90 degree, if it's actually going to 90 degree or not. Okay, that's something which is going to be very, very important. Then we have actuators such as the gripper and pneumatic cylinder for manipulating objects, okay, and performing tasks. Now, this can include different tasks, of course. Sorry. Which means that, let's say you tell a robot to lift a box, okay, and you tell a robot to, lift a lot of bricks from one place to the other, okay. All of these places need high power actuators, which means there are going to be like muscles of the robot, okay, and the bigger or the powerful the actuator is, the more the lift of the weight that the robot can carry. And this differentiates a robot's use case. Of course, if you have an autonomous robotic crane which is going to pick up things on its own, it needs to have a very different orientation. And if you don't have such kind of use case, then it needs to have a very different kind of orientation, of course. Then you have control systems such as PID controllers and neural networks for regulating or checking the behavior of the robot. Okay, and this needs to be having a different kind of approach altogether, where the robot, of course, can take upon different use cases and can build upon different networks and get built upon a lot of strength on its own as well. But PID controllers are like one of the most popular ones because they have extreme reliability, of course, and they have the possibility of extending this use cases and extending this behavior to a lot more different areas as well. Okay, very important. Now, in conclusion, building blocks are the basic component that are used to create robotic systems, which allow for robots and machines to have a very differentiated or have a very streamlined process when it comes to understanding and building robots. Now, these all systems are, of course, designed for different use cases, and they have a lot of capabilities, of course, as well. By combining different blocks, it is possible to create a robot with different functions and capabilities. You can increase or decrease the capabilities depending on the number of components which are there. And it also will differentiate how many robots or how much operations can a robot be used for. Okay. Hypothetically speaking, the more the number of components are there, the more options you can have. Okay. If you want to have a robot which can fly, then you add propellers. If you want a robot that can also walk or move on the streets, then you need to have wheels. If you want a robot that can swim as well, then you need to have some sort of floating devices. And if you combine all of these things, okay, you have a robot which can fly in the air, move on the street, and also go underwater or go over the water. That's a very complex system, okay, but it's definitely possible to build one. I have seen a couple of people building such systems where it has a hovercraft to float on the water, it has wheels to walk on the streets, and it has propellers to fly in the air. Very complex system, highly inefficient, but it's still possible. We are just telling you. Understanding building blocks is essential for designing and building effective robotic systems. Now, you need to understand that, building blocks are essential because every robotics engineer knows that a big problem cannot be solved in one shot, and every robot system needs to be broken down into simple, small steps, which require you to, have a very good analysis and have a very good planning, of course, and then you can achieve that. And that's it. We are done for this one. I hope you understood. I hope you had a lot of fun, and I hope you learned something. Let me come. And in the next video, we'll talk a lot more in detail about all these building blocks that we talked about. And I hope you're having fun. I'll catch you in the next one. Till then, happy learning and peace.